Here we go, guys. We are on CLT practice test number 2, looking at question 102. It says a sports equipment company needs to package baseballs into boxes for shipments to outlet stores. If each baseball has a radius of 1.5 inches and the baseballs are perfect spheres, then how many baseballs would be able to fit into a cubic box with one side measuring 24 inches? Assume that each layer of baseballs has the same number of balls as the layer beneath it. After the first layer is placed in the box, each successive layer of baseballs is placed directly on top of the layer below it. So we're filling baseballs into a cubic box. So cubic box is going to be, I'm going to take a square. That looks about the same. Woo. And then I'm going to make it into a cube. Give it a front and then connect. And on my cubic box, if one side measures 24, if my length is 24, then my width is 24, and my height is 24 inches. And now we want to take this box and pack in baseballs. Each baseball has a radius of 1.5 inches. So the sphere, the baseball, has a radius from the middle to the edge is 1.5. Then the diameter all the way across is 3 inches. So if I was packing baseballs into this box, 3 times how many gives me 24? I could fit 8 going across the length. I could fit 8 going across the width. And I could fit 8 rows of those baseballs going up the height. So it's just 8 times 8 times 8. I know that 8 times 8 is 64. And I know that 64 times 8, 8 times 4 is 32. 8 times 6, 48. Plus 3 is 51. Woof, wow, I can fit a lot of baseballs into that box. I can fit 512 of them. Wow, be like a really heavy box. Wonder what it's made of. But not too long because I want to wonder about these questions instead. Okay, number 103. In the diagram below, triangle XYZ is isosceles with line segment XY being congruent to line segment YZ. Angle Z, if angle Z measures 35 degrees and YW is parallel to ZX, they're parallel. What is the measure of angle WYZ across here? Okay, so there's a couple different ways that we could look at finding that angle, right? We want to find the measure of this angle right here. I know that over here, this little piece is parallel lines cut by a transversal, right? Because that could keep on going if it wanted to, right? So we'd have parallel lines cut by a transversal. So then these two angles would be congruent. So this little piece over here is 35 degrees. I know that my three angles inside of my triangle have to add up to 180. And if I can find this angle, then I'll know this angle. And I also know that these two angles right here add up to 90 degrees, and these are congruent. So 90 minus 35, my 0 becomes a 10, my 9 becomes an 8, 10 minus 5 is 5, 8 minus 3 is 5. So this little piece is 55, as well as this little piece is 55. So we've got 55 plus 55 plus 35, 5, 10, 15, 5, 10, 13 plus 1, 14. So our whole angle is going to be 145 degrees.